So our first example in the use of linearization is to use a linearization of a particular function to find a value. What we're going to do is use the linearization of the function f of x equals the cube root of x to find the approximate value of the cube root of 7.9. So let's put up here, just to remind you, the formula for linearization. Linearization of f at a is equal to, we call it L of x, and it's equal to f of a plus f prime of a x minus a. That was the formula. So let's use that. So first of all, let's find the linearization of the given function, the cube root function, at x equals 8. So we can say that in this case, it's clear that a is equal to 8 in that formula. We know that if f of x equals the cube root of function, we can rewrite that as x to the 1/3. So that means that f prime of x is equal to 1/3 x to the negative 2/3, which can be rewritten as 1 over 3 times x to the 2/3. So what we're going to need here, we're going to need f of a and f prime of a. So let's see. Sorry, since a equals 8, f of 8 is just going to be the cube root of 8, which is 2. And f prime of 8 is going to equal 1 over 3 times 8 to the 2/3. 8 to the 2/3 is like taking the cube root of 8 and squaring it, so that's just going to be the cube root of 8 is 2, we square it, and that gives 4. So that's going to be 1 over 3 times 4, which is 1/12. Alright, so we can now answer the first question, which is L of x is going to equal f of a, so that's going to be f of 8 plus f prime of 8 x minus 8. That's how we apply the formula with a equals 8. Plugging in the numbers, we get that's equal to 2 plus 1/12 x minus 8. So that's our first answer. This is the linearization of f of x equals cube root of x at x equals 8. And let's actually just be visually clear about what we just found. What we found here is that if we assume that the cube root function looks at least a little bit like this, looks kind of like the square root function, but it's not exactly. And if I put in, let's say, a value of 8, what I actually found was the equation of this line. In other words, the red line is y equals L of x, the purple curve is y equals f of x. I'm sort of drawing it in an exaggerated fashion, but that's what I found, is this function L of x is just the tangent line at x equals 8. So alright, so now let's use that to find the approximate value of 7.9. All we have to do is simply calculate L of 7.9. So that's going to be 2 plus 1/12 7.9 minus 8. And notice, by the way, that we moved horizontally from 8, but we moved in the other direction than we did in the introductory video. So basically here is going to be 7.9. So it shouldn't surprise you that we're getting a negative number here, because the horizontal distance that we move is leftward, so we're getting a negative number. The formula still works regardless of which direction we move in. So in any event, this is going to be 2 plus 7.9 minus 8 is just 0.1 over 12. I've calculated that. This comes out to this is actually negative 0.1 plus negative 0.1 over 12. So I've calculated what this fraction comes out to. It's going to be a negative number, so I'm going to subtract. That comes out to 0.008333. And then this comes out to, if I subtract that, I get 1.991667. So this is an approximate value of the cube root of 7.9. And by the way, don't ask how many decimal places you should use. It'll be clear from any problem. Obviously, if this were a test, we would tell you how many decimal places to use. That's not really all that important at this point. So anyway, so this is the approximate value of the cube root of 7.9. Now, how well did we really do? Well, according to a calculator, the actual cube root of 7.9 is still, we're getting the huge decimal, so it's an approximate value, but it's 1.99162. You can check that on your own calculator. So as you can see, we got pretty close, but it's not the same value because the whole point is that this tangent line gives you a pretty good approximation of a curve, but it's not exactly the same. So hopefully this makes the case that the tangent line does give you a pretty good approximation. Visually, let me just be clear about what we calculated. This purple dot here is has the actual y value of the cube root of 7.9, but let me put it in green. The green dot here, which would be on the tangent line, is the approximate value of the cube root of 7.9. So that's what we did.